One of the main impacts of XML external entity attacks is that they can be used to perform server-side request forgery, also called SSRF attacks. During this video, we look at a scenario where an attacker exploits XML external entity injection to deliver SSRF attack and get access to backend system inside a private network. For the purpose of this exercise, we use a lab from Web Security Academy, and you can find the link to this lab in the video description. To solve the lab, we need to exploit the XML external entity vulnerability to perform an SSRF attack and obtain the server's IAM secret access key from the EC2 metadata endpoint. Alright, let's jump in and get started by clicking on Access the Lab. The application homepage contains a list of products. We choose one of these products and click on View Details. At the bottom of the product page, we see the Check Stock function. This function allows the application users to check the available items of this product in a particular store. First, we turn on burp intercept so we can capture HTTP requests. Then we choose a city from drop-down menu and click on Check Stock. Looking at the body of the HTTP post request, we see the application is using XML for sending data to the application server. The first line is used for XML declaration, and it contains the XML version and the character encoding. We also see two XML elements. One of them is for product ID and the other one is for store ID. These elements contain the ID of the selected product and store. To do some experiment with this HTTP request and to see if it's vulnerable to XML injection, we can use burp repeater. So let's right click on this request and choose send to repeater. Now we can turn off burp intercept and go to the repeater. Let's first send this request without making any changes to the XML document to see the application normal response. So in the request tab, we click on send. The application returns 200 HTTP response code, which means the format of the submitted request was as expected, and the request contained no missing or invalid data. And in the body of the response, we get the number of available items for the selected product. Now we are interested to see what happens if we change the value of the product ID element in the HTTP request to an XML external entity. To exploit XML external entity injection, first we need to define an external entity using the URL from which the value of the entity should be loaded. Then we need to put the entity reference inside an XML element, which in this case is the product ID element. Let's take a look at the payload that we can use to deliver SSRF attack in this application. The external entity is defined inside the doc type element. The entity keyword is used to declare the XML entity followed by the name of the entity. The system keyword is used to declare this is an external entity, so its value should be loaded from the provided URL. From the lab description, we know the IP address of the internal server, so we have used that IP address in the URL that we want to target. So far we have defined the XML external entity and the URL from which the value of the entity should be loaded. We also need to put the entity reference inside an element inside the XML document. As we see, we have put the entity reference inside product ID element. So if the application is vulnerable to XML external entity injection, then we should be able to perform SSRF and receive the response from the specified backend system URL within the application response. Alright, let's go ahead and check if the application is vulnerable and we can get access to the backend system. In the burp repeater, we go to the body of the request and add the external entity declaration after the XML declaration. Then we need to put the entity reference in the product ID element. Now that we have injected our payload, we can go ahead and send this request. The application returns an error message, invalid product ID, followed by the response from the metadata endpoint, which seems to be a folder name. We copy the folder name and add it to the URL in the external entity, then send the request. We get another folder name. We need to repeat the same step until we find the secret access key. Finally, we find the admin URL. So in the HTTP request, we update the URL within the external entity and send the request. This time the application returns a JSON object. As we see, the return JSON object contains the secret access key. So we managed to obtain the server's IAM secret access key from the EC2 metadata endpoint. If we go to the web browser, we see the message that we have solved the lab. During this video, we saw how an attacker could exploit XML external entity injection to perform SSRF attack and get access to the backend systems. I hope you enjoyed watching this video, and I'll see you in the next videos.